So for our next panel, titled State of the State's Water Quality, we have just about invited half of the state up here to talk about it. So we have a robust panel, and to introduce the 7 panelists for this next session, I'd like to call up to the stage Dr. Dan Snow. Dr. Snow is the Director of Services for the Water Sciences Lab at the University of Nebraska-Lincoln. And for this morning's session, he will be both moderator and presenter. So please welcome Dan.
Did you get the slides? Well, thank you, Jesse. I really appreciate the chance to visit with you and lead the discussion on the state's water quality. Just a little bit about myself. I grew up on a farm in southwest Iowa, Montgomery County, and I was actually sampling and testing water in grade school. So it's something that was kind of in my blood at an early age. I went off, got a bachelor's degree in geology in Missouri. I went on to work in geochemistry in Louisiana and came back to Nebraska to study groundwater. I actually picked up a journal article while I was at LSU, and it was published by the National Groundwater Association. And at that moment, it's what I knew what my calling was to study groundwater. Nebraska had a very well-known program in groundwater, and I have never regretted coming to the state to study the resource that we all share. Well, I'm going to lead off the talks talking about groundwater nitrate in northeast Nebraska, try to give us a really quick summary of the research that's gone on in about 10 minutes, and hopefully set the stage for the rest of the talks that we'll see this afternoon or this morning. Next slide. There we go. Well, Nebraska is not alone in contemplating groundwater nitrate. These 2 maps were published by the USGS study from the National Water Quality Assessment Program. It basically shows that multiple states are impacted by groundwater nitrate. Washington, Oregon, especially California has been a lot in the news lately. Of course, Texas, Kansas to our south, and then Wisconsin, Minnesota, and even on the East Coast in Maryland. Pretty much any area that has high agricultural activity has been impacted by groundwater nitrate. So we're not alone in dealing with this problem. Went to the Nebraska Agrochemical contaminant database, which is online and publicly available, and just looked at the data that we have available to understand kind of how we got to the place that we are today. I downloaded about 15,000 results for nitrate concentrations from Antelope, Knox, Holt, and Pierce County in northeast Nebraska between 1970 and 2015. And one thing that struck me right off the bat in looking at this data was that even in 1974, we were having issues with high nitrate. So it's not something that just has happened in the last few years. It's something that we've slowly become aware of over time. But actually in the 1970s, when I was still in high school, we were already faced with nitrate issues. If we look at the average, which is that blue line through the data points, we already had hit, at least on average for those 4 counties, the 10 part per million maximum contaminant level for nitrate. That also corresponds to the time when we see a rapid increase in nitrogen fertilizer use. And a lot of the research that was done in the 1970s, 80s, and on into the 90s and early 2000s really focused on the rise in nitrate, rise in nitrogen use, and kind of the causes and effect for groundwater nitrate contamination. The study on the left by Mary Exner and Roy Spalding, Evolution of Contaminated Groundwater in Holt County, Nebraska, is really the first major publication dealing with nitrate contamination in northeast Nebraska. And they noted that there was a steep rise in nitrogen fertilizer use between 1968 and 1975, from about 5,000 to 20,000 tons of nitrogen applied in Holt County. At the same time, there was a steep increase in irrigated crops. So those two things together contributed, is what they indicated, contributed to the rapid increase in nitrate in our shallow groundwater in the northeast part of the state. A more recent study by Richard Ferguson on the right-hand side shows the trend in nitrogen fertilizer use for the whole state. We're starting out at about 50,000 tons for the whole state in 1955, and then it levels off in about 1980 at almost 600,000 tons of nitrogen, and then it just gradually increases from that point. So it's really that period between 1960 and the mid-1970s is when we saw increased use, increased productivity from agriculture, but also consequences to the state's groundwater. Exner and Spalding and Aaron Hurst published an article in 2014 that really kind of summarized what we have learned over the past several decades as to what factors are contributing to nitrate contamination in groundwater. And basically, the summary is that we have a higher risk for high nitrate groundwater in areas with a shallow water table, very thin vadose zone, which I'll talk about in a minute, sandy soils, and a high density of irrigation wells. Aerobic groundwater really comes about as a factor when we see rapid recharge. So the faster that the aquifer is recharged, the greater the likelihood that our groundwater is going to be contaminated with nitrate. And they identified regions through the Central Platte and in northeast Nebraska that consistently showed high nitrate. And over time, from the 1980s through the 1990s and early 2000s, how those areas had increased in size. A study that was just published this year by Dr. Ray's PhD student also looked at the whole state. It used data from the Nebraska Agrochemical Clearinghouse, a great resource, by the way, to understand nitrate contamination and other agrochemicals. And then put all that information together with some other recently available data into a statistical model. And that also showed the issue of high nitrate is related to areas with a shallow water table, short distance to the groundwater, a very thin vadose zone, sandy soils, and a high density of irrigation wells. Especially in the eastern half of the state, those factors are clearly emerging as predictors for high groundwater nitrate. In reviewing this article and the previous articles, I have to think that maybe the sandy soils, the shallow sandy soils, are really the biggest factor and maybe offers the greatest chance for controlling nitrate leaching below the root zone. I love to work with maps. This map was published recently by the Nebraska Conservation and Survey Division, and it shows the important aquifers and topographic regions of Nebraska. The High Plains Aquifer System. Let's see if I can use this. Whoops, I didn't use the pointer. There we go. Does the pointer work? It's the round button. The red button. Ah, there we go. High Plains Aquifer is basically the entire western 2/3 of the state, and then the valleys, the topographic regions of valleys, these river valleys, Platte River, and then the Elkhorn River are areas that have a shallow water table, very sandy soils, and short distance to the water table. And if we overlay that nitrate map that Dr. Ray showed a little bit ago, we can start to see the pattern between the hydrogeology, basically the topography, and the chances for or probability for high nitrate groundwater basically are in those river valleys, the sandy soils, short distance to the water table. So the same two maps spread out on this side, and then looking at the density of irrigation wells, We see the highest density of irrigation wells through the Central Platte Valley. We also see a very high density of irrigation wells in northeast Nebraska. And those are the same regions where we see the greatest concentrations of nitrate in the groundwater. A fourth factor that I think is really important that we now have an opportunity to study more closely is recharge rate. And this map, published by Joe Zloggy from the School of Natural Resources, indicates that northeast Nebraska in particular has a very high recharge rate. So circling back to the Brazil groundwater management area, one other factor that I think is pretty important in looking at most of the data is that a lot of the special protection areas or areas where we're really focusing our efforts on for groundwater or nitrate contamination are also stream headwaters. So the Brazil groundwater management area is actually the headwaters for 3 different streams, the Elkhorn River, Verdigris Creek, and Brazil Creek. It's no coincidence, I think, that these are also zones for special protection areas in other parts of the state. And it's not really surprising then what we would expect to have higher recharge rates in stream headwaters. So I think these areas in particular deserve special attention in working on ways to control nitrate leaching. And then finally, to talk a little bit about the vadose zone, that region between the crop root zone and the water table. This is actually a fairly simple diagram of the vadose zone. We've done a lot of coring over the past several decades looking at the vadose zone, and it's way more complicated than this. But even this figure shows you how much variability there can be in paths of recharge. Once that nitrate is leached below the root zone, it has several different pathways that it can take that could affect nitrate concentrations. The diagram on the right actually shows nitrate concentration in the vadose zone at the Nebraska Management Systems Evaluation Area. We collected core samples in 1994, and then the dots below the water table show how comparable that vadose zone nitrate is to the groundwater nitrate. Basically, we're just making a straight shot between that unsaturated zone to the water table, and we only have probably less than 20 feet of a vadose zone at that location. So in summary, we see a rapid increase in groundwater nitrate that coincides with a very steep increase in nitrogen fertilizer use in the 60s and 70s. Vulnerable areas across the state have a shallow water table, a thin vadose zone, sandy soils, high irrigation well density, and rapid recharge rate to the water table. I think stream headwaters in particular are very vulnerable to higher groundwater nitrate, and that vadose zone is a transient reservoir for nitrogen that I hope we learn a lot more through additional monitoring. And that controlling nitrate leaching is the key to reducing accumulation in the vadose zone and at the water table.